So in this one, we're trying to prove that angle ABE is going to be congruent to angle AECD. And there's a couple ways to do this. And it doesn't matter which one you choose to do. You're given that you have two different parallelograms. This is one of the parallelograms, and then this is the other parallelogram. And so the two methods that people would employ on this proof is, first, you can either prove the two triangles that those angles in are congruent, or second, you can just use parallel lines. I'm going to go ahead and do the parallel line method. And so you're given that A, B, F, E, and B, C, D, E are parallelograms. That's your given. Notice that you're not given any parallel lines. And if you want to use things like, for example, alternate interior angles, which is what we're going to use, then you need to claim the parallel lines. And so since ABFE is a parallelogram, that means AB is parallel to FE. And then since BCDE is a parallelogram, then that means what we're going to need is BE is parallel to CD. And so, and both of those can be put in the same step because their reason is exactly the same, and that is just the definition of a parallelogram. We know that the definition of a parallelogram says a quadrilateral where opposite sides are parallel. Now, the reason that's good is because we've got some transversals. BE turns out to be a transversal of AB and EF, and so we can say that angle 1 is congruent to angle 2. And then we also know that angle 2 is going to be congruent to angle 3 because EC is a transversal of BE and CD, and so we can say that angle 2 is congruent to angle 3. And that's just by the alternate interior angle theorem. And then finally, because we've got 1 is congruent to 2 and 2 is congruent to 3, we can say that 1 is congruent to 3 by the transitive property of congruence. And so that allows us to see, show that angle ABE, which we label as angle 1, is going to be congruent to angle ECD.